Okay, in the second step, what I'd like to do is raise a question and a problem. So at the end of the last video, you should have a device 0 class, which has just two values, name and value, a device manager, which manages an array of devices. It has a couple of constructors, an add method to add devices. It has a get method and a toString. Okay, so it's fairly straightforward. So let's assume that after a long period of time, we've got one type of device, this is managing that type of device, and everyone's happy, and a few years have passed or some period has passed. But then someone comes along and says, you know what, this device, actually what I need to have is another piece of information stored because we're finding this value isn't enough and we need a second piece of information. So that then creates a number of questions. Well, what should we do? Okay, we could go back to the device 0 class. We could just add it in, and let's say it's value 2, and then add it into the constructor, change it all. Now, superficially, this is a very simple class, the one that I've designed. But in reality, your classes will be much more complex. And the idea that you go back to a piece of code that you've built, a class that you use as an object, and you start changing the code internally is something that we want to try to avoid. We want to try to avoid it because we may break our original code in order to add a new feature or a new member variable. So that's one problem. Second problem is actually the mechanics of changing this original and the ripple it has through the system. You know, we've got this device which is managing this type of device. There may be methods which sit on it, all kinds of stuff. So we've got a little bit of an issue here that we really don't want to edit this original file, but we want everything that's in it, but we want to extend it. We want to add stuff. And this is where this concept of extending a class comes from. So what we're going to look at in the snippets, you have a device 2. This is the example we're going to look at. This class extends the device, adds a member variable, has a different constructor, has a set get method, and its toString method adds in the extra variable. So this is a very simple example to show how we can extend a piece of code. So I've got my device 0. The other question you might want to ask then is, well, the device manager is only managing this device 0. I want it to be able to manage the extended class, the new one with the added features. Will this still work? And this is where it gets very clever because the answer is yes. So how do we do this? Well, this currently has two member variables. They should technically be private, so I'm not quite sure why I forgot them, and if you corrected them in your videos earlier, that's very good. Okay, it's got a bunch of public methods because this is used. There are other scenarios where this class, we won't go into all the combinations because the power of this type of coding is you can combine an almost infinite variety of ways of doing a piece of code. Okay, we want to add another member variable, a constructor which allows you to initialize it, set and get methods, and the toString method to include this second value. But we want to do it without editing the original file. So what we do, this is the clever bit, is we create a new class. We'll give it a name. Okay, we're going to call it device2. To keep this, I'm calling it device2 only to keep it in sync with the snippet code. So if you do want to have a look at what the code looks like in another version, this will synchronize with that. And finish. So this gives us our usual blank class. And now this is where it gets really quite interesting. If you look back at the snippet, we need to add these two words at the end of that line there. And then some very interesting possibilities open up for us, but we'll take this in stages. First thing we want to do is just add that, I pressed the wrong copy and paste. So let's go back to that. Okay, so we've got that line there. So what we're going to say is we want this to extend the device we've already created. Now it's unhappy with that, and it's unhappy with that mainly, well, this is what we'll see. We'll have a look at what it says. There is no constructor in this device too. And that's crucial. If we're going to extend the original device, we need to extend, and we need to have its own constructor. Now, before I do anything else and properly add in my extra value, second value, let's just have a look at how that constructor, version of that constructor might work. So this is going to actually be closer to the snippet code of device 1. So bear with me a second. So let's just create a constructor which mirrors the constructor for the time being from the very first. It has 2 parameters, right? So let's mirror that first of all. But we have to call it device 2 because that's the class. We're going to pass it the same 2 parameters. Now we've got an interesting situation here. Again, it's not entirely happy because I've got nothing in the body. It's going to say cannot be applied. We need a little bit more. Okay. Now the issue here is that where are the member variables? Do I want to do this? We know that one of the member variables is called name, and we want it to equal device name, which we had in the original. Oh, hang on, it says it's private in the original. In the original, it was private. If you remove that, it would work, but we don't want to edit the original file at this stage. But we want to initialize it with this input device name in the constructor. Oh, how can we do that? That's private. Well, we know that the get name, set name are all public. So one mechanism is to do this. We could go set name, which belongs to the device 0. And it seems a little bit happier with this. It's saying device data cannot be applied to given required string, found no argument. Da-da-dum, da-da-dum. I'm not quite sure what it's complaining about here, but we'll come back to that. Let's have a look at device 0 a second. Yeah, there are only 2 parameters, so that should be fine. Okay, what we'll do, we have a problem here. We can use set name, but it's not, the issue is that if we use set name, and this is also why we have this error, it's just taken me a second to spot that, is because what happens to the constructor on the original class? In the original class, we passed it 2 values and they set the values. But this one, we're just setting it directly and it's not happy. The code is not happy with that. It's because we are not using the constructor. In order for this constructor to work, we have to piggyback off the original constructor. Now, how do we get access to device 0's constructor? Now, this is where we get a new term. If we extend device 2 as an extension of device 0, device 0 is called the superclass. So we can say super, open bracket, and pass it device name, and I'll explain what I'm doing, device value, which are the 2 values, right? Just gonna get the spelling right. You notice, oh, hang on, it wasn't happy with that. Let's just get that in as well. You notice now, suddenly, there's no error mistake, no issues at all. So let's just recap that, because it's a very, very peculiar type of issue. I'm just going to undo that, take us back a step. We try to use the set name, because if we're just extending it and we use a constructor, why can't we just literally use the set name method and set these values? Because where we've got access to them. Nope, it's not happy. One thing, the logic of constructors is that you have to use if it has one, the constructor, the superclass, the class you are extending, you have to use one of its constructors if it has some. Whenever you have values, then you have to use it. But let's just re-look at the code that we did. We wrote super. We didn't write device 0. We didn't write this. Because this may be your way of saying, well, you know, I'm going to run the constructor and it's called the same as the class. It's not happy with that. And it's not happy because when you want to write a constructor which uses the original constructor, you have to use the word super. And the word super means this. If this class extends from that class, device 0, is the superclass of this class. Higher, this device 2 is called the subclass of that class. So we have these two words, sub and super. Now if I use the word super and I pass in the two values, that's another way of directly using the constructor and getting access to the constructor. So what we're doing in this moment is passing in two values to this device, and it gets passed in through the constructor of the original class. Now, all of this has to be very careful, and the reason I'm very hesitant is that there are so many different ways that you can do this and the implication of each of these. So we are going to take a very limited, because this is introductory, approach to it. So bear with me as we code this through. To code it, you just write the word super and pass them in. Problem solved. Now, we can go back to our test file, and actually let's copy our test file and create a new test file. So we can just do one for, and refactor that copy and call that test3. Okay, so this constructor, bear with me a second, this constructor, this test file is entirely related now to the new class. So we can make sure we don't muddle up all our various different classes. So I've added a new class, and let's have a look at how the code actually changes. So I've got a device 2, which at the moment has no extra data it's storing, no more member variables, no other methods. It's just got a constructor, and this is just to illustrate how these things fit together, called device 2. And well, does it still work? So look at device manager. Device manager apparently only looks at device 0. But here's a really interesting thing that happens. If you point to the superclass, device 0, you can still manipulate the subclass. What on earth does that mean? Let's have a look. In test 3 now, I create my device manager. I've got 3 items, but for the sake of, we'll just reduce it to 2. Let's get rid of these extra ones. Get rid of those. Right. This is device 0. This is device 0. Let's change this to device 2. Right. So it's device 2, and it's got 2 parameters, phone and a number, just as we had before. Okay. So that's all right. So with the first one, we created a device 0. Then the second one, we created a device 2. Might be easier if we call that device 2. Okay, just to make the numbers of things fit together. We come down, we add the first one, which was a device. Let's get the numbers all correctly. We add it to the device manager. When you run the add code, you are simply it thinks you're just passing in the superclass, right? Or device 0. But look what happens on this line here. Hang on, I'm adding my subclass, my child class. Another way of referring to it is that the superclass is your parent class and this is your subclass, and it's not complaining. Interesting. Hasn't complained. So here I have created a different class which just extends the original class, its superclass. It's got a simple constructor which just calls the constructor of the root of the superclass or the base class or the parent class, all similar. Let's run it and see what happens. So far it looks okay. So let's update it. And interestingly, we are literally updating. The phone is device 2. So we are getting hold of, well, watch what we do here. We've got 0 and 1, right, that we're adding. We can simply just store it as device 0. Now this is where it might get confusing. So really, technically, this should be, we're going to store it as device 2. But it throws a problem. It's because it's expecting to return, if you look at the get method inside device manager, it's expecting to return, where is it, get device 0. It's assuming it's returning that superclass. If you're not confused, you might be. So it still seems to work though. I seem to be able to pass it back. I seem to be able to set a value. How can I set a value on device 2 when it's got no set value? Because it extends, it basically, it's like adding in extra lines to this class and calling it device 2. That's essentially what this does, but it always has to have its own constructor. That's just a peculiarity, right? But I can still set a value and it will still all work over here. That's interesting. But this is not passing me back. I'm not storing device 0, I'm storing device 2. So how come it was happy for me to take it back? Now this is really, really complex and abstract with a lot of theory involved. And my instinct is that for the time being, I want you to focus on the practicalities of this, and then we'll discuss the theory maybe in a separate video. So practically, if I create a new class, device 2, and I extend it, the minimum requirement, if my original class had a constructor and had values being passed to it, I have to replicate that one of them and call the constructor from the class I'm extending. Once I do that, at this stage, I can pretty much treat my new class as if it's my superclass. Now, so far, so good. Now, if at this stage you're confused, just go back and code it. So let's go back to this, and we've coded that. But what happens if I add a second value? So instead of literally typing that in device 0, renaming this to another one, and rather than put it there and then adding all the code in there, I'm writing it in a separate file because I'm extending it. So as per the rules, every member variable has its own get set methods. I'm going to be lazy. I'm going to grab, it's going to be a value. So I'm basically going to grab that set value method. Go back here, paste it in here, and let's call it set value 2, right? And value 2, and this is device value 2, and just make sure it's also just to indicate that this is a new piece of information. Okay, let's go back and let's get its get method. It's the nearest one it looks like is this get value. Go back to there. Let's drop it in here. It's not get value 1, get value 2, because that's what I've called my member variable, and I want to return value 2. Okay, so that looks, it's not complaining at this stage. That looks reasonably okay in terms of a procedure. I'm matching these for my member variable. But there's one last thing in my device 0, and that's this toString method. It returns the name and the value in this format. But I want to add a third value. I want to add value 2 into that. So how do I do it? So do I do this? Do I grab the original one and where am I going? And simply add another line, and in that extra line add it? So I could do this. Right, so value 2 equals that. Let's get rid of that space there. In fact, let's probably make a little bit more space, do it like that, right? And that should be value 2. Well, it's complaining for two reasons. One is that it can't get access to name. So we want, instead of here, we would want get name. And instead of value, we would want get value. Now you might think, where are they coming from? Well, actually they're in the superclass, so you can save yourself a little bit of confusion by if the method comes from inside your superclass, then use the word super, because that refers to device 0. But why repeat the whole chunk of code if the superclass is already doing the first 2 numbers? That's an interesting proposition. So instead of these 2 lines, what happens if we get rid of those and we say, let's just run the superclass 2 string, get the return from that, so run that, get that return and store it, and then add to it our new line. Will that work? Let's go to the test file. In the test file, I am going to, when I print, I am going to, if we go to my device manager, when I look at what it does, it loops round the devices, some of which are now going to not just hold device 0, but its subclass, its child class, device 2. Will this code work? Will it still be able to execute the toString method on that item? What it will do is it will, of course it will, because device 2 has a true toString method. So it'll run that. When it runs that, this internally is calling the original one. So should we just test that out? So what we're saying is let's run that and see what that does. Now this is interesting. For the very first item, which was device 0, only had 2 values, which are what we displayed. But for the second one, and here, initially we didn't declare what that second value was. That's why it's 0 here. So maybe we should have given it an original value, right? And it's not happy with that. Why is it not happy with that? Device 2 cannot be because we haven't got a constructor to allow us to do that so far. Look back at device 2. The constructor just says 2 values. So actually we want a third value in here in order to allow us to actually send in an initial value. Before we get back to that, so what you notice is that I've got a value 2. It's currently 0, it's currently 0, right? But what happens if we do that? Set value 2. If you look in device 2, we've got a set value 2. So why don't we grab it, store it here, and then we try to run it? Oh, but it's not happy. Why is it not happy? Because actually this set value 2, it thinks that it belongs to device 0. Go to device 0, there is no set value, there's only set value 2, there's only that. In the child there is, but not in the parent or not in the superclass. So it's not happy with that. Actually what we really needed to do was make that device 2. We needed to store it, and this is where it gets really, really quite tricky. This thinks it's returning a device 0, the superclass, but we want to store it as the derived class. So we have to, in front of here, put the word device 2, because what that will do is it adds another step. You notice it's not complaining now, so really pay attention to this and go back through this carefully. This get method on the device manager passes an index and returns device 0, but actually we know that we're storing one of the child classes in the space of where the parent is. Okay, go to here. Go to here. So what it's doing is it thinks it's passing back a device 0. By putting this bracket in front of it with device 2, it forces it to say, no, actually, it is a device 2. It's one of the child classes. And so we can temporarily then hold on to it. And then when we called set value 2, we are calling it on the right class. Set value 2 doesn't belong to device 0. It only belongs to device 2. So then it allows us to update it. So if we run this, it should go from 0 initially because we didn't initialize it. And down here, the updated value is 47.99 and it's happily received it. So actually in the constructor is the last piece missing, and we're going to stop after that. Let's go back to device 2. Device 2 should really have a third value. Think about it. It should have some way of taking in the new value. Because when I build the object, I've got the previous two values, the name and the original value, which go to the superclass. That sorts those out. But here, I also want to be able to initialize my original value. So if I go to the test code and now I put in a bracket, it's happy to accept a third value. So let's just call it 56.001, just for sake of argument, right? Let's have a look at what happens to the code now. We run it, there it is, the new value, 56001. We updated it down here. It's now changed it to 4799. So that's all I want to do in this initial video. There's a lot more to be done here, and I'm very, very conscious that I'm trying to get you to learn how to do this coding differently, but try to keep the theory to a minimum. The theory can be extremely difficult and abstract and difficult to follow. So we need a different strategy if you're going to learn to code in it, and then we'll explain at some point what the meaning of these things are. But the logic to review, and I will review, is that we had this original class, had two private member variables, but I wanted to extend it for a third member variable. Rather than fiddle around with this class, I simply added a new class and used the word extend. So this is literally that with a few extra bits. This is the parent class, or the base class, or the superclass. They're three words that you often hear connected. Whereas this is the child class, or the subclass, or the derived class. So in this class, I simply add the extra piece of data. I write a constructor which takes in all the values. So that's from the superclass and from this new one. So inside it, the constructor will call the constructor of the superclass, and then I will initialize my new value. I have set and forget values for my new piece of data. And when I run toString and I set it up, I call the original toString and get the results of that, add it into there, and then add in my extra. Now, this is very easy to get wrong and very easy to muddle up. So I would work very cautiously and make sure you can code up to this point here. From this point, if you look at snippet 3, we've essentially replicated snippet 3. Snippet 4, which is we're next up for, is we are going to add another derived class to extend the idea. So from our point of view, looking at this and playing with this and making sure it codes is essential.